Hi, I'm Kelly Scott Sims, and this is my walkthrough project number 2, temperature sensor on the Arduino. For my project, because I have an R4 Wi-Fi and not a long enough serial cable, I decided to actually implement data transfer over Wi-Fi. So I'm going to walk you through everything that I did here. Um, the first thing that you have to do is actually provide the config for your Wi-Fi, and this is just SSID, the local network, and then the password for it. In our setup function, we have a few different states that we transition to. I went a little overboard on engineering this, and we'll see why in a second. But we start off in an uninitialized state, and here is where we will actually set up the Wi-Fi. So if we look at setting up the Wi-Fi here, it's pretty simple. We just pass in our SSID and our password here, just using generic libraries that you can use. And then it'll establish a connection with the Wi-Fi. And not only that, but it'll also print out the IP address of the Arduino device, and this is important for the next step. Once we've established a Wi-Fi connection, we actually set up a UDP server, a UDP listener. I chose UDP instead of TCP because it's fire and forget, and I didn't want anything clogging up the transmission line for multiple retries in case a packet failed. I'm okay with losing packets instead of clogging up the transmission line. So we're setting up a UDP listener on a port here. Um, After we've set up a UDP server, we begin a timer here. I'll circle back to this. This requires a little bit more discussion, so we'll skip that. So after we set up Wi-Fi and our UDP listener, we now need to sync our clock. Obviously, when we take temperature measurements, we need to send the time that the temperature was taken. So we have a couple different ways to do this. We could have added another library to sync the clock through some internet site or things like that. But it was actually a little bit easier to have whatever client that's going to connect to the microcontroller just pass the time to the microcontroller and set it that way. So this is actually a blocking call, and it'll wait for somebody to connect via UDP. And we can see if there's a packet that comes across, we expect that the first packet sent from the client is a Unix timestamp. And from that, we basically parse the string to a time, and then we set our local clock against the Unix timestamp that was sent to us from the client. And that's how we update the microcontroller and keep it in sync with its time. And like I said, subsequent temperature readings will reference this beginning timestamp. After we do that, now we transition to a connected state. And then we come into our main loop here. Connected meaning we have a remote client who's connected to us via UDP, and we have successfully synced our clock off of their message that they sent. So now we are going to transmit some options to the client. And all these options is they have the ability to start transmission or in temperature transmission, and they can send that one at any time and sever the connection. Um, Once they've given us our option, and that is blocking as well too, we transition to a ready state. And the ready state is what listens for the option to come back from the client. So we're waiting for them to give us option 1 or option 2. If we look into there, we can see, yeah, see, we're looking for option 1 or option 2. Depending on what's given to us, we transition to a transmitting state or a done state if they have rejected to start transmitting. Good. So once we're in a transmitting state, this is where we're actually reading our temperature sensor. So we have a DHT11 sensor, and we can see over here that we have it connected here. It's a 3-pin sensor, where the first pin is the data pin, the middle pin is the VCC, and the far right pin, right if you're looking at the face of it, is the ground pin here. Because it already has a built-in pull-up resistor, we actually don't have to add one in there, so it's a simple plug and go. And when we're in a transmitting state, we are going off of this global volatile variable here, ready to read temp, and we'll talk about where this one gets set. But if this is set to true, we come in here and we immediately set it to false. We read our temperature. I'm using the DHT library that comes from Adafruit, I believe it is, that they already do the conversion from Celsius to Fahrenheit from you if you just pass true into here. And then we'll log what the temperature is that we're collecting, and then we get the current time. Remember, this is the time that was set and has elapsed since we've gotten the Unix timestamp from the UDP client, and then we transmit that back over as a C string payload to the client in UDP. So let's talk about this ready to read temp here. So this is, like I said, a volatile Boolean that is set to true by our ISR handler. One of the things that happens in our setup here is we have this begin timer function. So if we go to begin timer here, we can see that we are setting up this FSP timer. So this is a library that can be used with the specific platform that I have here. I've already forgotten what it is. The I'm going to say it wrong. Renaissance Raw platform that you're able to use the FSP timers with this platform. One of the problems with this timer, though, is the counter that it uses internally. Basically, it increments a counter based off of how many cycles of the clock it sees. But one of the problems of it is this counter is 16 bits. So it's not very good for timing and doing things over a long interval, say 10 seconds. The amount of counts that it takes to get to 10 seconds overflows this 16-bit integer. So what I ended up having to do is we can see here that as I'm beginning the timer here, I'm setting the timer mode to periodic, which means that it will keep replaying over and over and over. It's not a one-time timer. And then it invokes this timer callback, where I have this timer callback here that it's incrementing yet another global volatile variable, which is set up here somewhere. Yeah, right here to count. So I can go as low as 1 second or as long as 1 second with the timer, which means every time my callback is invoked, I need to increment this tick count to get me to the full 10 seconds that I need. So basically, I'm incrementing tick count. Once it gets to 10, reset the tick count, and then we set the global variable to true. And that's what's happening in our ISR so that we're able to keep monitoring on the main loop for any state transition changes, but then also see that our global variable here is updated. So right now I'm hardwired in because we are Wi-Fi. I can run this off a battery, but I'm hardwired in right now because I want to show the serial monitor of what this looks like. So if I start monitoring here and let me reset the device, reset it one more time. Yeah. So you can see that getting a Arduino Wi-Fi address there, and then now it's just waiting for a UDP connection. And I have built a Python UDP client here. It's actually quite a lot of bit of code because basically I will be doing a real-time streaming graph updates. Since that's not the main focus of the project, I won't go too deep in that code. But I do have a UDP client here such that once we run this, I think it's client app. You'll see we send an initial Unix timestamp, and then we've gotten the OK from this response that it has successfully set the time, and now it's giving us our options here of what we want to do. And then we can see here in the serial monitor that it's also been set as well. So if I don't actually want to do anything, I can hit 2, and this will kill the connection here, but it'll also reset the application state of the microcontroller to now wait for a new connection. And then I can just run this again and it'll connect as we expect. So I'm going to hook up the battery now, which means we'll lose the serial monitor. Let me stop monitoring. And then we'll actually start plotting in real time now. So I'm just running it off of a Duracell 9-volt battery. And we're just going to plug it right in. Okay. And now we should still be able to just connect as we did. We send our timestamp, we have our options, and now we'll push 1 to actually start receiving. And we're receiving our temperatures now. Let me make this a little bit bigger. Cool. So we're getting around 74 and a half, 74.6 degrees or so. And yeah, we can see that this is updating in real time every 10 seconds. And we'll let this stabilize, and after it stabilizes, we'll actually go ahead and take it over to our freezer, where we'll let it drop and transmit us some more data. Okay, I think we're pretty well stabilized there, so let's go ahead and move this over to our freezer and see what we get. Okay, so now it's in the freezer, and you get to see just how small Swiss freezers are. I wish I could say it's only ours is that small, but no, that is the typical Switzerland freezer size. It's quite inconvenient. But yeah, now we can start to see that the temperature is beginning to drop. So it's been around 5 minutes or so, and we can see that the temperature is dropping. Granted, I didn't close the freezer door in there so that we could see that it is still in there. Had I closed it, it would have dropped a little bit quicker, but we can see with each iteration it is still dropping. So if I left it in there longer, even with the door open, it would still keep dropping. So with that, let's go get it and bring it back to room temperature. Okay, we have it back here now. And we're going to give it 5 minutes to let it go back up to room temperature. Okay, and that's about 5 minutes. It's taking a little bit longer than that to come back up to normal, but we can see that it is coming back up to room temperature. Just going to take a little bit longer than 5 minutes. So yeah, that's the demonstration here. So let me stop this. And we will go through quickly what the UDP client looks like. So we have a client app here at high level. I won't go through too terribly much of it, but you can see that it's getting the IP address that was recorded by the microcontroller in the port 12345, and then we're doing a plot interval here. This is basically tells the plotter to refresh and redraw every 1 second here, even though we're only receiving every 10 seconds. It's still doing it every 1 second. I could probably actually bump that up to 10 seconds. I don't know why I set it for 1 second. So then in the we're saving the main thread for plotting only, and we don't block that. I'm actually starting two different background threads. The first one here is for listening for user input, so it can still see that I am putting in options or typing. And then we'll get to where the second one is in a minute. But then I have this data manager here that manages the shared access, where shared access to the data being the temperatures being written across from UDP. That obviously is being mutated from the UDP whenever a new entry comes in, but it's also being read from the plotter when it wants to plot new data. So it's making sure it's managing that access in a thread-safe manner. Here it's just basically establishing the socket, sending the Unix timestamp, and then yeah, it's making sure that we got an OK from the server, and then yeah, providing the options here of one or two so that it can be sent back. And then here's the two threads being started. So the thread that's being started for receiving the data, and then also the input thread here. So this is the one that I showed earlier that still listens for user input. And then for receiving data here, this one is the one that listens for the UDP data and parses the CSV string. So it's constantly listening for the new data and then adding it into the data manager, in which the data manager itself, let's go back up, data manager. You can see this manages the shared data. It's mostly doing it by using a mutex here, a lock mutex, or semaphore, some of you may know it. But yeah, basically using a lock here in order to read or update the data, you must first acquire the lock. If you don't have the lock, you can't do anything, and you must wait for whatever thread that does have the lock to give it up before you can read and or mutate the data. Then going back to the main thread here, it's yeah, just basically creating our plot and then continually updating it with the new data and then rendering the plot. So yeah, that's the walkthrough for my implementation for the temperature monitor. Thank you.